Okay, this last example is interesting because if you try to do just like how we solved the other ones, you see that it's an integral is almost impossible to solve. However, if you change the viewpoint where instead of integrating by dx, you do integration by dy, suddenly it's something that you can do. Okay? So let me show you how this is done. So I want to first give you the failed attempt.
Can you only recognize it by trying one way and then doing the other way to figure it out?
Well, if I put this on the exam, I would actually say that you have to integrate by dy's, just so that you don't have to spend all your time doing the other wrong one. Yeah, but if this was given to you and you have to find it exactly, then you would have to do both ways, and first attempt will give you something you can't do, and you try the other one.
That would be very, thank you for doing this.
Yeah, that would be very fun, right?
Yeah.
Okay, so let's do the fun thing. Try the failed attempt. The arc length is sum of its parts, and we know that this is square root of dx squared plus dy squared. And because we don't know how to do this calculation, we divide by dx, multiply by dx, because we only know how to integrate things when dx is at the end, right? And when you bring this inside, you get dx squared over dx squared, which gives you 1. And dy squared over dx squared will be dy over dx squared.
That dx is squared then.
No, when this is brought inside the square root, this becomes squared. Okay? When it's outside, it doesn't have a square. You go inside, suddenly it has a square. Okay? And then you have dx, and the integral is from 0 to 1. Okay, dy dx is needed, so let's try that. Dy dx means you differentiate 1/2 x 2/3. Which gives you 2/3 times 1/2 x to the negative 1/3.
1 over 3.
So it's 1 over 3. It's 1 over 3 x to the negative 1/3. And if you square this, you get 1/9 square of this would be times 2 there. So you end up with the integral from 0 to 1 square root 1 plus 1 over 9 x to the negative 2/3.
So far.
And, I mean, at this point, you feel like you have to give up, right? Can you do this? And, like, not me, it'd be too much, right? So that's the failed attempt. Okay. Now, if the question was just find the approximate value, then you could just put this into a calculator, or if you can't use the calculator, you can use Riemann's sum. But apparently this can be found exactly. So let's try the second attempt. Where we start with the same ds, but instead of dividing by dx and multiplying by dx, you divide by dy and multiply by dy, right? And the result of that would mean that you have dx over dy squared, dx over dy squared. And then dy squared over dy squared will be 1. And you have to integrate by dy. That means we have to do two things. First, we have to know what the bounds are. So when x is 0, y is 1/2 0 to the 2/3 power, which is 0. When x is 1, y is 1/2 times 1 to the 2/3 power, which is
1.
That's just 1. 1 times 1/2 is just 1/2. So that's what goes here, 0 to 1/2. But then, what does dx dy mean? It means that you have to think of x as a function of y, which means you have to solve this for y. So let's do that. Multiply by 2, so 2y is equal to x to 2/3 power.
How would you say that?
What's the question?
Because like if it was x to the square, you just say you square the other side. I mean, square.
How
the
do you
other
solve
side.
this? I'll show you. Yeah, you just exponentiate both sides by 3/2.
Oh, because
But then we know that if you have two exponents like that, they multiply, right? And the result is that you have 2y 3/2. This time this is just 1, so you have x to the first power, or just x itself. Therefore, dx dy means you have to differentiate 2y 3/2 prime, so that 3/2 comes down, subtract 1, which is 1/2. But then instead of being y, it's 2y, so there's something extra you have to do. What?
You have to differentiate 2y.
Yeah,
to multiply.
you have to use a chain rule. So it's times 2. 2 and 2 cancels. So you end up with 3 times 2y. 1/2 power square root, so it's 3 times square root of 2y. Okay, good. Now we can plug that into the formula. So it's the integral from 0 to 1/2 of square root of 3 squared is 9, and 2y square root squared would be taking away the square root, so it would be just 2y plus 1 dy. 9 times 2 is 18y plus 1 to the 1/2 power, 0 to 1/2 dy. And this is again the formula that we used in the first example, right? This 18 produces what? What does this 18 produce? 1/18. And then 18y plus 1, you add 1 to the 1/2, so it's 3/2. Put the reciprocal, 2/3. And then you have to plug in 1/2
54.
and 0. Well, 1/2 of,
Oh, so
I see. But, you know, this and this can reduce, so it's 1/27. So that's outside. When you plug in 1/2, you get 9. 9 plus 1 is 10, so it's 10 to the 3/2 power. When you plug in 0, it's just 0. No, it's 1. 1 to the 3/2 power, so it's 1. So that's the answer. Yeah.